you've been doing well. This is going to be a continuation of our Python software engineering interviews series. So, like I said, I'll be having two segments whereby I will be having the beginner Python series and I'll be having the Python software engineering interviews challenges series. So, this is a continuation from the previous video, and we're going to solve another question which is oftenly set during software engineering interviews. Okay, so the question here is that we're supposed to write a function which will help us determine whether a string is a permutation of a palindrome. I assume that you've either come across the word palindrome. So a palindrome is actually a word which can be written the same way, both forwards and backwards. So an example could be madam, race car, kayak. You notice that when you write these words both forwards and backwards, you come up with the same word. So that is what a palindrome is. Another thing, a permutation is just an arrangement of letters. So if you look at the words pot and top, you notice that when you arrange the letters in the words, you can come up with either the word pot or top. So that is an example of a permutation. So now that we've actually learned what a palindrome and a permutation is, we need to actually figure out what this question wants us to do. So we're supposed to find out whether a string is a permutation of a palindrome. So how do you go about this? Let's have this string, for example. We know that once you permutate this string here, you come up with kayak, which is a palindrome permutation. So we are supposed to write a function which will check all the strings that we've been given, and once the string is permutated, we should check whether it actually brings us a word which is a palindrome. So that is what the question wants us to do. So one more thing that we need to do is that we actually need to find out the properties of these words which form palindrome permutations. So let's look at kayak, for example. You notice that kayak has most letters which have more than one occurrence. We have two K's, we have two A's, and we only have one Y. If you look at madam, you notice the same thing. We have letters which have more than one occurrence, and they have an even occurrence, except for only one letter which has a single occurrence. Another example is a race car. If you look at the letters, the same thing happens. You find that we have letters that have an even occurrence, except for only one letter which has a single occurrence. So that is a property for words which are palindrome permutations. So once you know that, you'd actually be able to find a way of how to go about this problem. Okay, so how do we go about solving this problem? The best solution when it comes to solving this problem is actually by using a hash table. So let's go and solve the problem. Like I said on the previous video, it's actually a good thing to always think about the base cases. So in this scenario, I'm going to actually delete the white spaces, and I'm also going to actually change the string to a similar case. So then we delete the white spaces. And I do that by actually replacing the white spaces with no spaces at all. Another thing is that I could convert into a similar case. So it's actually a good thing to always comment your code. That is actually one of the best practices of coding. So I'm gonna convert it to a lowercase. And then after that, what we do is that we actually create a hash table or a dictionary. So and then we go ahead and loop through the string. And then if the letter is actually in the car set, or if the letter is actually in the dictionary, we go ahead and increment the letter. Otherwise, if the letter is not in the dictionary already, what we do is that we would go ahead and set the value to 1. We would go ahead and count it. So another thing that we are going to have is an odd counter. And this would keep track of all the letters which do not have an even occurrence. So and then we go ahead and loop through the entire dictionary. And then we go and check if the value modulus of 2 is not equals to 0, and the odd counter is equals to 0. In other words, we have not encountered any letter which has a single occurrence before. We go ahead and increment the odd counter. Else if the value modulus of 2 is not equals to 0, that is the letter has an occurrence which is not even, and the odd counter as well is not equals to 0. In other words, we have encountered another letter already which has an occurrence which is not even. So what do we do here? We return false. Why? We return false because this means that the string is actually not a palindrome permutation. You remember that we said the properties of palindrome permutation is that they have letters which have even occurrences, except for at most one letter which only has a single occurrence. So if we actually come across a string which has more than one single occurrence, or more than one occurrence which is not which is odd, we actually return false, because it means that the string is not a palindrome permutation. So otherwise, when you go through the entire loop and not come across anything, you return true. Okay, so let's go ahead and see if our code actually works. Let's try the string that we had created, and then if we go ahead and test this, it returns true. That is because once you permutate this, you actually come up with kayak, which is a palindrome permutation. So if we added something like C, so we have, in this case, we have two letters which have a single occurrence. We have C and Y. So let's go ahead and see what it's gonna do. It's gonna return false. Why? Because this is actually not a palindrome permutation. Once you permutate this word, you will not form a word which is actually a palindrome. So and that's it. Our code actually works, and I hope you've actually learned how you can approach this problem in case it's presented to you in any programming or coding interview scenario. So another thing is that the time complexity here is ON. So thank you so much. I really hope that you have learned something from this, and I look forward to seeing you in the next problem. And yeah, keep safe and take care of yourselves, and happy quarantine coding. So thank you so much. Okay, bye.